Okay, average rate of change. We need to find the average rate of change of f of x, given that f of x is x cubed minus x, over the interval 1, 3. Now here's a graph, just for reference sake, of f of x from here's where 1 is in the x-axis, and here's where 3 is in the x-axis. Okay? So they want the average slope from here, where it crosses to, it's just about here. They want the average slope. Well, you can see that slope changes as it goes from 1 to 3. And typically, to find limits and things, we use f of x plus h minus f of x all over h. However, if we have an average where we have 2 points, let's not forget that the average rate of change is also the same as the slope. So if I want to find the slope between these 2 points, the actual slope between those 2 points is the average rate of change for those 2 points. So what I really need to do is, if I were to consider these x points, 1 and 3, as letters, let's call this B and this A. Well, if A is 1, what's my y value? My y value would be f of A. In this case, it looks like it would be 0 on the y-axis. And if 3 is B, and I follow this up here, then f of B, the y value for that, would be something, and we'll calculate that out and fill that in. So I can just take my change in y over my change in x. And ultimately, what I'm going to do is just take f of b minus f of a all over b minus a. This represents my change in x. The top, or numerator, represents my change in y. That's pretty much slope from integrated algebra. So, let's figure out what's f of 3 minus f of 1 all over 3 minus 1. Again, these are x's, and these are the y's that we get from those x's. All right, let's figure out f of 3. F of 3, and again, I'm just going to plug 3 into our equation. So that is 3 cubed minus 3, which is 27 minus 3, which is 24. Okay? So this right here is going to turn into 24. And that's pretty accurate, because it is just below 25. It's pretty good. Now, what's f of 1? Well, I'm going to put a 1 in here now. F of 1. That is 1 cubed minus our 1. 1 minus 1, and that is 0. So I'm going to take away our 0. And that's good, because that's what we came up with on our graph. All over 3 minus 1 is 2. So 24 over 2 gives us 12. That is the average slope on the interval from when x is 1 to when x goes to 3. All right? So ultimately, it's just the slope, which we just figured out, from the points where x is 1 and x is 3. And if we look at it, it's rise over run, correct? Rise over run, that's our slope. We rose from 0 to 24, right? So we rose 24, and we ran a distance of 2. 24 over 2, that gives us 12. It works in so many levels. Now let's do the same thing. Let's find the average rate of change. But our function is going to be different now. It's not x cubed minus x. It's x cubed plus 1. And we want to go over the x interval from -1 to 1. All right. Let's throw this up a little bit here. Here's -1 on the x-axis. Here's +1 on the x-axis. So from here That's roughly where it's 1. To here. Okay? Which means this value right here should give me what f of 1 is. And this value right here, should give me what f of negative 1 is. This obviously looks like 0. This looks like it actually might be the number 1. And our average slope, we'll go from there. Let's plug things in. In fact, before we plug things in, let's make a guess here. Well, our change in y would go from 0 to 1, right? So 1 minus 0 all over. What's our change in x? Our change in x goes from here, from negative 1 to positive 1, right? That's a distance of 2. So let's see if we get 1/2. Let's see if that works. All right? That's what we did when we did it the old-fashioned way. Now, let's use our f of b minus f of a all over b minus a. Again, this that I got right here is just an estimate. I'm assuming this is going to be 1. I'm assuming this is going to be 0. I won't know until I actually plug them in the formula. Okay? So, I'm going to take mine. We'll call this A and this B. So, f of B, which is 1, minus f of A, which is negative 1, all over B, which is 1, minus A, which is negative 1. All right? Well, let's figure out. F of 1, I'm going to plug a 1 in here, is 1 cubed plus 1. That equals 2. All right? So for this, I get a 2 minus, let's figure out what f of negative 1 is. Again, I'm going to throw a negative 1 into my function. That is negative 1 cubed plus 1. All right, if I cube a negative 1, I get negative 1 plus 1 all over nothing. I'm not at the fraction. This is where it's all over. Negative 1 plus 1 ends up being 0. 0. Let's put that in for this right here. 1 minus negative 1 is the same thing as saying 1 plus 1. That is 2. 2 over 2. Our slope should be 1. So where did we make a mistake? Our mistake was made right here. Because these tick marks aren't labeled, here's 0 on the y-axis, here's 1, and this is actually a height of 2. That is a 2, not a 1, which just becomes a 2. That's why it's all fine and dandy to try and eyeball things. But because my function here, as I followed it, actually covered the tick mark where 1 is in the y-axis right here, I didn't count that as 1. A lot of mistakes can be made, and so we've got to figure things out algebraically and solve for it. And there you go. Slope of 1. Slope and the tangent line. Right? These can sometimes be a little tricky, but only simply because there's sometimes a lot of algebra involved. And in this case, as I read this, I see that there's fractions involved, and it can get a little algebraically heavy compared to other problems we have. All right? So let's find the slope of the curve of f of x equaling 1 over x at the point where x equals a. Where does the slope equal negative 1/4? And what happens at those points? And what at point a comma 1 over a for different values of a? All right, there seems to be 3 or 4 things that we got to do here. And the first is, let's find the slope of the curve here, okay, right at x equals a. So we're going to find the slope of the function 1 over x, right where x equals a. This is not an average. We don't have 2 points where we can just take the change in y over the change in x. We have one spot where we need to take the slope from, which means we have to use this. All right? So, if my function equals 1 over x, then I need to put that into our f of x plus h minus f of x all over h. So let's do that. No other way to get it done besides to do it, people. So, I'm going to start by putting x plus h into my x here. I have 1 over x plus h minus our original function. Our original function is 1 over x all over h. And why do we got to do a lot of algebra here? Because let's not forget, this is what happens as our limit with h approaching 0. And this is going to be x equals a. So obviously you can't have a 0 in for h because it's in the denominator. All right? And that will make it undefined. So I'm going to algebraically manipulate this, and hopefully we can get rid of that h in the denominator. The first thing I'm going to do is I'm going to break this up, all right? Meaning, I'm going to take the numerator and break it up and multiply it by 1 over the denominator. That means I'm going to take 1 over h and multiply it by 1 over x plus h minus 1 over x. Because if I do that, technically this is over 1, right? I can do that. That's fine. All right? So now what do I do? Well, ultimately, this h right here has to cancel off. I want to try and get an h in the numerator. All right? I want to try and get an h in the numerators here. I'm going to combine these fractions right here, and hopefully that gives me an h on top. That's the goal. So in order to combine those two fractions, let's not forget our basic algebra. Our denominators have to be the same. So I'm going to multiply this fraction here by x and x, okay? And I'm going to start to rewrite this. 1 over h times x over x times x plus h. All I did is I applied this multiplication. And I'm going to multiply the second fraction here by x plus h, top and bottom. All right, so minus, when I combine these, I get x plus h over x times x plus h. Now, both of these fractions have the same denominator. I can now combine them. And let's see what happens when I combine them. All right? I'm doing a lot of rewriting just so you guys can see every step. As you guys get good and fluent with this, you can skip some steps, but not too many. All right? So I've got 1 over h times, well, the bottom is going to stay the same. All right? What's the top going to be? I have x. Now let's not forget, I'm subtracting this whole expression. So I've got to distribute that negative sign. Minus x minus h. And the beautiful thing that happens here is positive x and negative x cancel. So when I rewrite this, I still have the limits as h approaches 0. It's x equals a. I don't want to forget that. And now I have 1 over h times negative h all over x times x plus h. Now something nice happens here. This cancels with this, and I have like a negative 1 up here. When I multiply them, 1 times negative 1 is a negative 1 over x times x plus h. Now I can throw a 0 in there. This right here won't hurt me because it's gone. I can throw a 0 in for h, and the letter a in for x. So I'm going to now apply these. Okay? I'm going to have negative 1 over, I'm going to put an a there, time, I'm going to put an a here, plus, I'm going to put a 0 here. That's not an O, that's a 0. So I have negative 1 all over a times a plus 0 is a. That's negative 1 over a squared. That's the slope at any given point on our function. Well, at specific point, I'm sorry, at the specific point, x equals a. If I put my x back in, here's the slope at any given point. But they want to know when x equals a. So that's why we came here. All right? That's the slope of our function right at the point where x equals a. So now that we have that, now it's left to right. Okay? Where does the slope, this is the next thing we're going to answer. Where does the slope equal negative 1/4? Well, I know if my slope is negative 1 over a squared, and I want to know where does this equal negative 1/4? I don't know, we just got to make sure we can find out where a squared equals 4, don't we? Where does a squared equal 4? Well, I take the square root of both sides. When a is equal to positive or negative 2. That's where my slope will equal negative 1/4. That was a lot simpler compared to the work we just did. All right? Now, what happens at those points? So, what happens right at the points here? Well, let's not forget, x equals a. So let's look at our graph where x is positive and negative 2. Okay? Here's our graph. Let's have a nice picture of our graph here. Well, here's a positive 2. Here's a negative 2. What happens at these points here and here? Well, if I were to draw a tangent line, it would kind of look something like that. If I were to draw a tangent line here, it would kind of look something like that. That looks to me a lot like parallel lines. All right, that looks to me a lot like parallel lines. So what happens at those points? Well, the tangent lines are parallel. The tangent lines are parallel. And last but not least, what happens at the point a, comma 1 over a? I'm reading this right here. What happens at the point a, comma 1 over a for different values of a? So let's figure out what happens. What happens, now again, x equals a. We can't forget that. So what happens to a, or x equals from here to here, to here, to here, to here, and so forth. And vice versa, what happens as x goes from 0, or a, goes from 0 to 1, to 2, to 3. Well, let's look at the tangent lines. Look at the tangent line at 2. Now, what happens to the tangent line at 3? It levels off. Okay? Then if you go backward, it's a little bit steeper, doesn't it? Same thing here. This is steeper here, but as I get further and further toward the left side of negative infinity, it gets more level, or more horizontal, more horizontal, more horizontal, and so forth. So I want to be a little up. All right? So what happens for different values of a? Well, it looks like the lines stay parallel for the negative and positive versions of a, meaning this line here at negative 1 is parallel to this line here at positive 1. But as I go further and further to positive infinity, if I go further this way, my tangent line starts to become more horizontal. Same thing, as I go this way, it becomes more horizontal. So let's write this. As a, or x value, goes, or I should say approaches, because this is calculus, approaches positive and negative infinity, the slope approaches zero. And what does that mean if it's zero? Horizontal line. That's what has the slope of zero. Alright? That was a lot of work. That was a lot of work because there are fractions involved. And it asks us 3 or 4 more interpretive questions, basically. Alright, slope and tangent line. Again, let's do the same thing. They don't ask us as many questions. But let's find the slope of the curve of the function x squared plus 2. Thank God there are no fractions involved. Right at x equals a. Okay, describe what happens to the tangent line as it changes. All right, we kind of just did that, so we kind of got a good feel for what we did. So first things first, we need to throw this right here into our buddy. This is our buddy. And I'm going to put x plus h into this function first. So I'm going to have x plus h squared plus 2. Don't forget, you always got to have your plus 2. All right? And now I'm going to subtract whatever f of x is. Well, f of x, they give it to us. It's right here. So I'm going to subtract this whole thing, x squared plus 2, all over h. And again, this is the limit as h approaches 0. I want to get rid of the bottom there. I want to cancel it out with something in the top, because if we plug our 0 into h right now, it is undefined. All right? So let's FOIL this out. If I FOIL this, I get x squared plus 2xh plus h squared. We can't forget, we still have our plus 2 minus, well, I've got to distribute this. So that was a positive x. I'm going to turn it into a negative x. I had a positive 2 to a negative 2. All over h. And if I did this right, this back f of x term, after I distribute my negative, will always cancel. Which means I have a positive 2 and a negative 2. I have, squared. I forgot the squared. And that's why we check. That's how we know if we did this right or not. I have a negative x squared now. It's going to cancel the positive x squared. Now that I made that correction, I know I've done this right. All right, so I see the only thing I have left is here, and that's beautiful because everything has a h. Cancels one of these and this here. So last but not least, I have 2x and plus h. 2x plus h. Right? That is the limit as h approaches 0. Right at x equals a. So, if h is 0, plus 0. If x is a, 2a plus 0 is 2a. That is the slope right at the point where x equals a. Now, they ask us to describe what's happening to the tangent line as it changes. Well, here's the tangent line right here. Isn't this a horizontal line? As it moves to this point, it becomes more of a positive, 45-degree angle thing. From this point, it's a little bit more steep. And from this point, it's a little bit more steep. That is an approach, a vertical line. It's become steeper and steeper, more positive. And as I move back, it becomes slightly more and more negative as I go. Slightly more and more negative as I go. So what happens to the tangent line? It becomes more positive and more negative.